Hello, this file relates to the free convection heat transfer under lesson number 3. So the main contents of this file are the concept of free convection, how to determine the value of heat transfer coefficient H in free convection, and solution of the worksheet problem 9. So this is the continuation of the previous study material which is being uploaded in the Moodle. So as you know that we already discussed about the free convection in the lesson number 1 and also in the convection heat transfer also. Just I want to remind you some basics. So in free convection heat transfer, what type, no equipment will be there to make a system to lose the heat. So in free convection, the heat loss from the system to the surroundings will be very slow, okay, like in this case. So what happens in free convection, the heat transfer will be from the system, this is system hot plate, it will losing the heat very slowly in comparison with the forced convection, right? In the previous slide we discussed some problem with regards to forced convection, starting with Reynolds number, finding velocity, finding the turbulent flow, something like that. So in free convection, the idea of getting the H, okay, it's a little bit different, okay, so that is the thing. So for both the cases, to find the heat transfer rate for forced convection as well as the free convection, the formula is same. What is that? Newton's law of cooling, Q is equivalent to H A Ts minus Tf. H is heat transfer coefficient, A is area, Ts is temperature of surface, Tf the temperature of the fluid. Okay, in free convection, so there is no extra equipment will be there, so the particular system will lose the heat naturally or freely. So in this case, if you want to know the the procedure to find the, so what is the methodology to determine the heat transfer coefficient H in case of free convection? Okay, again repeating for you, in previous slide for forced convection, okay, we followed some step to determine the H. Okay, then only can find Q, because Q is equal to HA delta T, just now we discussed. For free convection there is a separate procedure. Okay, how to identify, okay, the given problem is free convection or forced convection, means main thing is that in free convection problems, velocity or mass flow rate will not be given. Okay, velocity and mass flow rate will not be given. So that is the main thing. Okay, if any convection problem, if there is no velocity or mass flow rate of the fluid, then you can tell that okay, it is a free convection problem, and the method to determine the value of H is like this. Okay, so in free convection problems, the first step is that we have to find Kirchhoff number. So it is given as GR is equal to L cube G beta delta T by nu square. L means everything is given here, name, L is length of cylinder, G 9.81, okay, acceleration due to gravity, beta, it is the coefficient which is given here, the formula, beta is equal to 1 over T average plus 273, the unit is 1 by Kelvin or K power minus 1. Okay, so T average, how to find T average? T average is, it is addition of Ts plus Tf by 2. So this data will be available in the question. Ts is what? Temperature of the surface, temperature plus temperature of the fluid. Okay, so you have to add it, then divide by 2, that's T average, then you substitute here that to get beta. So L is length of cylinder, G is 9.81, beta is just now we discussed. Delta T is same thing, Ts minus Tf. Okay, difference, delta is difference, right? So Ts minus Tf. So that is the top. Now then the by nu square. Nu square is the kinematic viscosity. So kinematic viscosity is meter square by second. Okay, so all those data will be available and in the problem. Then you have to substitute in the this formula GR, then get the value of GR. Okay, this is the first step. Okay, so again repeating for you, L is length of cylinder, G is 9.81, beta is this formula. So this TSTF will be available in the question, and substitute here, get the value of delta T, then by direct dynamic viscosity square. So this is the way to find GR. After finding GR, next step find PR, means Prandtl number. We already discussed in the previous slide also, forced convection, right? Same formula. Mu is dynamic viscosity, Cp is the specific heat, okay, K is the thermal conductivity. Okay, this one already we discussed in the previous slide. Okay, so dynamic viscosity, mu is dynamic viscosity, Cp is the specific heat, K is the thermal conductivity of the fluid. So find this PR. Okay, the first step GR, second step PR, you find it. Third step, find the multiplication of GR and PR. You will get some answer. Okay, the third step, find the you got the answer in GR, right? So that value here, then PR value, you multiply it, you will get some answer. Okay, so that answer will be big. I mean, you will get the higher big value. So keep it as it is. Then fourth step, you have to find Nusselt number. Okay, you have to find Nusselt number. How to find the Nusselt number means, again we have to check either that particular flow is laminar or turbulent. You have to check laminar or turbulent. So once you get this GRPR value, check that value is lying in between 10 power 4 or between 10 power 9. Okay, 10 power 4 between 10 power 9. If the value, for example, if I am telling you, okay, if the value say 5 into, for example, okay, 5 into 10 power 5. Okay, after multiplying GRPR, okay, if you are getting value as 5 into 10 power 5 means, then 5 into 10 power 5 is lying between this range, right? So 10 power 4 and between 10 power 9. So then it is a laminar. So you have to find Nusselt number using this equation. What is that equation? 0.59 GRPR power 0.25. So GRPR value what you are getting here, you substitute here, then raise the power to 0.25, then get the Nusselt number. Okay. And sometimes suppose if the values instead of 10 power 5 is 10 power 10 or 10, if it is 10 power 10 something like that, then that GRPR value will be lying in this range, correct? So 10 power 10 means it will be in this range. So if that is the case, then that type of flow is called turbulent flow. To find Nusselt number, you have to use this equation. You have to use this equation for the value if it is between 10 power 9 to 10 power 12. So this is the two formulas to finding laminar and turbulent. Okay, on getting the Nusselt number. Once you get the Nusselt number in the particular, for suppose if it is a laminar, say this value 5 into 10 power 5. Okay, so that one you have to substitute here to find the H. Okay, heat transfer coefficient. Then K value will be in the problem and divide by L. L is the length of the cylinder. Okay, then find the value of H. Then substitute in this formula. So H multiplied into pi, D is diameter of the cylinder, L is length of the cylinder, Ts temperature of the surface minus temperature of the fluid. Then you will get the answer for Q. Okay, so this is the method to find the heat transfer coefficient if the problem is free convection. In free convection, both mass flow rate and velocity will not be given. Okay, then you have to identify it's a free convection. Then you have to solve free convection problems. First you have to find Grashof number, Prandtl number, then GRPR, then Nusselt number, heat transfer coefficient, this one. Okay, again I am telling you all the formulas will be available in the question paper. We will solve one problem with regards to free convection. A vertical cylinder 1.5 meter high and 180 millimeter in diameter is maintained at 100 degrees Celsius in an atmospheric environment of 20 degrees Celsius. So here temperatures, two temperatures are given. Okay, height is L is given. Okay, diameter is given. Okay, calculate the heat loss by free convection. So the question is straightforward. So free convection from the surface of the cylinder. Assume the properties of air at mean temperature, density, this one, kinematic viscosity is given, specific heat is given. Okay, be careful, kilojoules you have to convert to joules. And thermal conductivity, be careful, see the unit. Okay, thermal conductivity units, it is given kilojoules, hour, something like that. So I told you many times in the class, if kilojoules is there in the problem, you have to convert it to joules. Okay, and here hour is there, you have to convert it to seconds. So in the top you have to multiply 10 power 3 and at the bottom you have to multiply into 3600. So you will get the correct unit of K. Don't forget this one. Okay, now you have to find, now what is the question? We have to find heat loss, means you have to find the Q. So the same step what we are discussed in the previous slide. Okay, so write this given data, everything is given, length is given, diameter, convert to meter, surface temperature is given, right? So Ts, this Tf, okay, 20 degrees Celsius, density and viscosity is given, Cp is given, K is given. The K we have to convert. I told you, so I converted K. So on the top kilojoules multiply 10 power 3, in the bottom you divide with 600. Okay, then you will get 0.029 watts per meter degree Celsius. Okay, K. Then here dynamic viscosity is given. I have to find mu dynamic viscosity. Why? Because then only I can find Prandtl number, right? Because Prandtl number is mu Cp by K. So how to find dynamic viscosity? We know this relationship, this formula. Okay, I think you remember the force convection we discussed this formula. What is the relationship between dynamic viscosity and dynamic viscosity and density? Okay, so this is the relationship in the problem. Dynamic viscosity is given, right? Then we want dynamic viscosity, then only can find PR, right? So here itself I am going to convert. So mu is equal to this one into this one, cross multiply. So dynamic viscosity is given, density is given, so multiply both the things, then you will get mu. Okay, 2.01 10 power minus 5 kilogram by meter second. Then beta, I told you just now how to find beta, 1 by 273 plus 2 TF. So TF is average, 100 plus 20 by 2, correct? I told you in the previous slide, 100 plus 20 by 2, 2 plus 273. So if you divide this one, you will get this answer, 0.003 Kelvin as for beta. Then for Grashof number, what is the formula? L cube G beta delta T by nu square. This is the thing. So L is given 1.5 cube, G 9.81, me 0.03, delta T 100 minus 20. Then dynamic viscosity square, this one. Okay, so just now is given. Then we got the value of us 2.208 in 10 power 10. Okay, so till here I think it's clear, right? So from the given data only I am writing I got beta. Okay, I got beta and GR, and also K I got after converting kilojoules to joules and hour to seconds. Okay, now we have found GR as 2.2 into 10 power 10. Now we have to find Prandtl number. Okay, what is the Prandtl number formula? Mu Cp by K. Here mu is there, already we found mu, correct? We already found the mu, substitute this mu value. Cp is given the problem, but be careful, Cp is 10 power 3, this is power, okay, 10 power 3, so it is wrong, 10 power 3, because here see in Cp in the question 1.004 into kilojoules, so multiply per 10 power 3. In K we know 0.029 thermal conductivity. Okay, then you will get Prandtl number as 0.6975. Okay, then next step what you have to do, we have to find the GR/PR, right? We have to find GR/PR. So GR we know 2.208, okay, in 10 power 10 and 0.6975 for GR/PR. Then we got this value. Now please check this one, 10 power 10. 10 power 10 in which range? Is laminar or turbulent? So 10 power 10 is lying between here. See, GR/PR 1.54, okay, 1.54 of this value is lying between 10 power 9 and 10 power 12. We discussed in the previous slide, right? So then it is that the flow is turbulent. Okay, then flow is turbulent. Then we have to use this formula. Okay, then substitute this answer here, here. Then raise the power 0.33 as per the formula. Then you will get Nusselt number as 248.79. That's it. Now we know this formula of H, correct? NUK by L. So NUK, you just note, you write to 248.79. K is given the problem. Okay, we got the K. Then divide by L. L is 1.5. 1.5. Why length is here considered? Because in free convection, the convection takes place from the length of surface. And the length of surface is very greater than that of diameter. So only we are considering here L. Then after getting a substitute formula, we got H. H is 4.433. Then substitute in this formula H. Okay, we know 4.433 H here. Then pi. Then D is given. L is given. Then T is also given. TF is also given. Then multiply using a calculator. You will get this answer. Okay, this is the step to solve free convection problems. Again, I am telling you, in free convection problems, mass flow rate or velocity will not be given. If it is not given, then you have to assume that it is a free convection problem. Then you have to start to solve the problem starting with Grashof number, okay, Prandtl number, then GR/PR, then Nusselt number, H, like this. Okay, all the formulas will be available in the question paper. Thank you.